Whenever you see the word stoichiometry, think mole to mole step. That's what stoichiometry means pretty much, is that you're going to be converting from moles of one substance to moles of another. With respect to gas stoichiometry, we are dealing with volumes of gases. So if we see STP, those three letters mean that 1 mole equals 22.4 liters. So you can only use that conversion factor when you're at STP. But if you're at STP, think 1 mole is 22.4 liters. Think conversion. There are other ways you can do this problem. Absolutely. You can do it using ideal gas law. But the easiest way to do it would be just to do a conversion where we take the 1.24 liters of hydrogen, cancel liters of hydrogen, go to moles of hydrogen. 22.4 liters is 1 mole. Then do a mole to mole step. So go mole hydrogen to mole water. You get the numbers for the mole to mole step from the balance reaction. So 2 moles of water, 2 moles of hydrogen. And then it's asking for grams of water. So cancel out mole of water, go to grams, 18.02 grams off the periodic table. And so this is going to give me 0.998 grams of water. If we start with grams, it's the same thing. Just going the other way, I'm going to go to liters of oxygen. It is at STP. So conversion, 1 mole is 22.4 liters. 10.5 grams water. 18.02 grams in 1 mole. Mole to mole step, so mole water. It's asking for oxygen, so mole oxygen on top, 1 oxygen, 2 water, and then 1 mole oxygen, 22.4 liters of oxygen. So you get 6.53. So if it's at STP, pretty easy, regular stoichiometry like you've been doing for quite some time now. If it's not an STP, it's a little bit more complicated. I'm going to actually do this one first because it's a little bit easier. So I have 5 liters of nitrogen. That's a volume. I have a pressure of 3 atmospheres. That's a P. Temperature 298 Kelvin. And we're looking for how much ammonia in grams is produced. It's not at STP. I cannot use 1 mole is 22.4 liters. So I have to get around that somehow. Looking at my variables, I can get around it by using the ideal gas law, where my pressure is 3 atmospheres, my volume is 5 liters, my N is unknown just because it's not given in the problem, R is a constant, 0.0821, T is 298 Kelvin. So N is PV over RT. So N is 3 times 5 over 0.0821 times 298. So that is going to be 0.6131 moles. Don't round too much at that step. If you want to even take it out a few more decimal places, not a bad idea. Now this is asking for how much ammonia in grams. And what I have solved for here is moles. But I've solved for moles of nitrogen because it was 5 liters of nitrogen. So then I'm going to have to do mole to mole step, stoichiometry, right? Always a mole to mole step. So 1 mole nitrogen, 2 mole ammonia, and then 1 mole ammonia, 17.04 grams. And so what you're going to get at the end of this is 20.9 grams ammonia. Okay. So you use the ideal gas law because you can't use 1 mole is 22.4 liters. So let's go back to the one we skipped. I want to know what volume in liters of hydrogen gas can I make at this temperature, this pressure, and then I have grams, which is an amount, but of course amount has to be in moles, so I will have to convert. So my pressure is 738 millimeters of mercury. For ideal gas law, it has to be in ATM, so I'm going to convert that. I'm going to get 0.917100526 atmospheres. My volume's unknown, and we'll come back to R is 0.0821, T is 355. Okay, so let's talk about N. N has to be an amount in moles. I'm given grams of methanol, so I know, okay, I am going to have to convert the grams of methanol to moles. So 35.7 grams methanol has a molar mass of 32.05 grams per mole. And so that's going to give me 1.11388 mole of methanol. If you look at the problem, it's asking for volume of hydrogen. So if I plug moles of methanol in to the ideal gas law and solve for V, that's not helpful because what I'm solving for there is volume of methanol. And because I can't use 22.4, I really don't have a way to get from volume of methanol to volume of hydrogen. So what I'm going to do then, if I'm looking for volume of hydrogen, my N has to be moles of hydrogen. And so then I will do stoichiometry, mole to mole step, 1 mole of methanol, 2 moles hydrogen. And so I'm going to get 2.7769 moles of hydrogen. That I will plug in for my N. And then finally, I will solve for V. So V is nRT over P. So 2.227769, 0.0821, 355 over 0.9710526. And I'm going to get 66.9 liters as my volume there. So look at what you're given in the problem. Look at what it's asking for. If it's not at STP, you can't use 22.4, so you're going to have to use the ideal gas law to kind of get around that.